Okay, I promised that we were going to work on some problems today. So I got us started on that. And I'm going to start with a fairly simple one. And I'm going to try and stop and start and record these in a variety of ways so that you guys can have them as individual problems instead of having to look all the way through. So we're going to play, I think this textbook, I've gotten at least one textbook that does the old Vincent Price, the pendulum in the pit kind of story. And so we're going to use a saw here that's on a pendulum. We're going to raise the pendulum up. So we're going to raise it to a certain height and then we're going to have it come sliding back down. And we want to know what the velocity of the blade is when it comes out to the bottom of the swing. But we're going to raise this up to a height of 1 meter. So we want to know what the velocity of the blade is at the bottom of the swing. And this is very similar to a problem that you might find on the MCAT. In fact, I found a very similar problem on the MCAT that actually says if I raise my pendulum up and I allow it to drop, exactly how is that going to work? So this is very much like that. So one of the things that we know is we know conservation of energy. We're given the mass that we have, and our mass is 2.5 kilograms. We're given the height that we're raised up to is 1 meter, and we want to find velocity. So velocity is what we're after. So if I use conservation of energy, the total energy at the top is going to equal the total energy at the bottom. Yeah. Now, the energy, if I think about what's happening at my pendulum, energy at the top is going to be energy due to position. So this is going to equal our potential energy. Energy at the bottom is entirely kinetic energy. And so we're going to use our kinetic energy at the bottom. So my energy at the top is going to be potential energy. My energy at the bottom is going to be kinetic energy. And now I'm going to be able to write my mgh. And my kinetic energy is 1/2 mv squared. Now, the problem actually gave us the mass of the pendulum. It didn't have to, because masses are going to cancel out. This will only come into play, and we'll see this when we start talking about momentum, which we're going to do. We're going to actually start looking at that fairly quickly here. But when we actually do momentum, we will have to play with that a little bit. But basically, I'm going to get 2gh is equal to my velocity squared. The square root of 2gh is going to equal velocity. And this will be the square root of 2 times 9.81 times 1. And that's going to give me my velocity. And so if we do that, I'm going to get 2 times 9.81, do the square root of that. And that says my velocity is going to be 4.43 meters per second. So this gets you an idea of how to play with those conservation of energy. So we're going to do another one. This one is going to look a little bit more like your one of the homework problems that you have. So we're gonna